Letter gets to the right.
Oh, okay,
I'm using him.
okay. So we don't have sky maps and calendars this month. They haven't sent them yet, but next month we'll have those. We usually hand those out. And but if you go to spotthestation.gov, I think you all have that website probably, but you can see when the space station's going over, and it went over around 6 tonight. And so there are a number of evening, you probably don't want to get up at 4 in the morning to see it, so that's sometimes it's set at that time. So I think Dewey, do you want me to introduce Leonard?
Well, I can't sit down and get things right. You're all done?
Yeah.
We ready for Leonard?
Yeah.
I'm ready.
Come on up, Leonard.
So yeah, our own local SkyWatcher, Leonard David Whitehead. He's in case you don't know, he's a writer about space exploration, award-winning writer.
I make her
Space
say
exploration.
that.
And
She gave me the
writes-
award though.
and he deserved it.
Yeah.
But yeah, and he writes for space.com and Space News and Scientific American sometimes, and has his own website, which is just leonarddavid.com, and posts all the other stories that he writes on there, and a whole lot of other articles, brief ones that with pictures and video links in some cases, and
Some days they have a lot of fun.
yeah,
I
right.
mean, some days.
Some days it's a lot of
Stop.
work. Yeah. So Dewey's working on it now.
Let me look.
I got to get the
Okay.
clicker to work.
Yeah.
Do this.
Anyway, no, so I bet John's gonna talk about this, but have you all seen Venus in the West?
All right. The clicker.
Jupiter rising, now it's rising like later. Orion's up there, that's my favorite constellation. And Saturn, I guess, is, I think John will probably talk about that, but in the south, is that? Yeah, yeah, I just haven't been out there to look at it through our glasses. Yeah, and Judy, did you send any pictures or have any, that you want to share? Yeah, so maybe at the, Leonard will do his talk, and then John, who's in Santa Fe, will give us a perspective on astronomy. And then if anyone else, either on Zoom, wants to share any of their astrophotography, we'd love to have them do that. And okay, you ready?
It's been, 2024 when I look back, and I wish I wouldn't have signed up to do this because, there was so much going on. I mean, it was an amazing year. It's not over, but wow. I mean, there was a lot of things happening globally, and I think that's one of the messages. What's wrong? Did I do something wrong already?
I did. I forgot to share screen.
Uh-oh. New.
I was like, how can I have broken it all?
Way to go.
And the people at home are probably going, it's just this tiny little picture up on the screen.
I know.
That's not going to work.
All right.
Okay, our Zoomers, are you seeing the full screen now?
Hope so.
Yep. We are.
Okay.
All right, now,
That's better.
so given that I'm not quite sure what I'm going to talk about, I do want to start with a couple of things about the future, because as a journalist, I'm kind of paid to be optimistic, but yet pessimistic. You kind of have to go right down the center there. And I think we're headed for some really, 2025 is going to be a very interesting dynamic of our space program, what our space program is. And I'll get into China and other countries. And I think that's one of the messages. You gotta broaden this out, because this is becoming a global enterprise. United Arab Emirates and name a country now, they have a space agency. And so there's a lot of things going on. Room for cooperation between countries. Also room to be aggravated by other countries and their capabilities. So it's going to be a really interesting year coming up. Let me start here with the thing that is intriguing. Okay, I pressed the right button, right? Is that,
Yeah, with the right arrow, did that not move?
no? At least I'm not sure. I don't know. Did it move? Okay. We have a new person that President-elect Trump has brought on.
No.
Jared Eichselman, and he's a very interesting character. A young guy. Barb and I were lucky to meet him not too long ago before one of his missions. He's flown twice in space. I almost think now it's really amazing. The NASA administrator should have flown in space. And it's been a pattern that's been growing over the years, and nobody's paid too much attention to it. But even the current administrator of NASA, Bill Nelson, is a senator from Florida. He flew on the space shuttle. And I really start to think now, one of the check marks of your administrative leadership role is that you flew in space and you got to look down and participate in the overview effect and what that means to you, and also understand all the technology involved and what it takes to get a person off the ground on Earth and into space. So it's kind of an interesting new guy coming in. One of the things that's very fascinating about this particular person, he's flown twice. He's an entrepreneur, billionaire. He may have some heat giving the Congress is going to have to do, obviously they go through these sound checks with everybody that gets picked by Trump. And so he's got his own issues that he's going to have to deal with. Is he too sensitive or too favorable to Elon Musk and the SpaceX crowd because they launched him twice? So there's going to be a really interesting debate. The guy is great. I mean, from a personal standpoint, we enjoyed talking to him. He's just a wonderful guy with a lot of ambition about space. This morning I watched a great talk by him at Embry-Riddle, where he kind of brought on his vision of the future for young new students coming out of Embry-Riddle and what he thinks is going to happen in the future. Pretty bold. Unfortunately, one of the bad things, again, about being a journalist, I've met probably almost all the administrators for decades. And, they get in there and the road gets tough. Things happen. People are expecting too much of the person to change the dynamic. It's a little bit like the Valdez when you're up, trying to maneuver a ship with oil on it and crashing. There's 18,000 people at NASA. They have a budget about $25 billion. The National Academy of Sciences just in the last couple of months ago said NASA is at a crossroads. It's in trouble financially, has too much on its plate. Infrastructure is not up to par. And it was a pretty damning report about the space agency that people think is really working well. He's got some issues, and I don't know if he's the right guy at the right time. Could be. But anyway, that's my angst on that one. Okay, next slide. Is that working?
Yeah.
That changed. Okay. And, one of the big backers, obviously for Trump, and most likely have a great influence on having this new NASA administrator choice is Elon Musk. And he invited Trump to the last Starship mission that took off and was very successful. Unbelievable, it's a skyscraper rocket going off. And Elon has very impressive, ideas about multi-planet species. He wants to shove a number of people on these starships and getting them off to Mars, landing on Mars and starting a new kind of civilization. Big dreamer, lot to happen. Starship, the next flight of it is probably in a week or so. They just tested the engines on the Starship. It's kind of ready to go again. So we'll see how this next flight goes. One of the things to watch is NASA has bought into the Starship, and it is one of the key elements for landing astronauts back on the moon. There's so many steps that Starship has to show, and Elon is ready to go because he's cranking these out like Ford Motor Company. I mean, it's unbelievable if you go down. I've talked to people that have been in his shop. It's fantastic. He's got quite a unbelievable production crowd that's I can go on the webcam and look at every morning. They're working their brains out down there in Texas to getting the next Starship together. So it's a very exciting period of time. Elon is clearly a guy that's got a vision about the future. How out of focus it will be in the next administration, I have no idea. But he's doing something nobody's done before, and you can't discount his innovative, creative spirit. It comes at a time, however, as I was saying, about the National Academy of Science did a study about NASA. On the left there, my left, you see the report, NASA at a Crossroads. And again, this is, frankly, again, I'm too old for this stuff, but I've gone through a lot of these NASA at a Crossroads reports. They've come and gone over the decades. This one, to me, was more serious than I've ever read. I mean, I've read them all. And it just pointed out a lot of issues that NASA has way too much on its plate. Even at $25 billion, 18,000 people working hard at NASA, field centers that have equipment that is not working very well. One wonders just how NASA is going to be able to operate in the efficiency that some people expect it to, including the new administrator. So we'll see what kind of changes are going to come. On the right there is, the crew of Artemis 2. They are going at some point in the future out beyond the moon and come back and come screaming in and do a circumlunar flight. So, and they've been waiting for this mission for quite a while, and they just got the word they're going to have to wait another year because they've slipped the whole program over to the right. So this particular crowd's not going to go as we thought in next year, but in 2026, with eventually Artemis 3 would be the first U.S. boots on the moon since 1972 to put people back on the moon. So NASA is definitely an agency that's slipping to the right. And again, I'm trying to be objective and worried at the same time. And I think we got a lot of issues that a new administrator is going to have to face. So we'll see how that irons out. Because, what the deal is, we're going to the South Pole of the moon. Now, the big question is, so is China. So is Russia. So is India. So is Japan. Things are moving very rapidly about getting to the moon. And just a few weeks ago, NASA honed down a bunch of different kind of landing sites for the first crewed, I always call it rebooting the moon. And this is what NASA foresees in the South Pole as potential landing sites. They're tough, they're different. They're not Apollo-like, they're not equatorial. These are up or down in the South Pole. And there's a lot of interesting terrain to deal with and landing, and also the sun is at a different, it has a different foreshadowing. Maybe Bob, this is a good point for you, Bob. Bob is got a new mission that's just about ready to take off next month. He has an instrument on it, and maybe Bob, you can just do a little 5 minutes on it, or a couple of minutes.
Is this the end of the moon? Is this the next spot?
Well, I think so.
Okay. So yeah, the South Pole is the big focus for, somebody goes to next to Leonard.
Now, you're,
Okay.
lighting's better there.
Okay, the South Pole is the big focus because of these areas, because the moon doesn't have, its axis is not tilted with respect to the sun as much as the Earth's is, so there's these areas of permanent shadow that it's thought that ice has accumulated there from cometary impacts over billions of years, and so it would be a resource for people to use. It's going to be hard to get to. It's actually, nobody's really found it yet, but the exploration continues, and all the betting money's on the South Pole. There will be a series of robotic landers that are supposed to land there over the next couple of years, including one called IM-2, Intuitive Machines 2. That's flew its first spacecraft last year. You may recall there were two robotic landers went to the moon. One kind of half blew up in Earth orbit, and they took it around the moon and brought it back and crashed it into the atmosphere. The other one got to the moon, and just as it landed, it tipped over. But nobody got any science back from it, and very few images. So that company, the tipping over company, Intuitive Machines, is making their second launch attempt and landing attempt this winter.
Now, the good thing about this, to be good about it, NASA has invested with, it's a private, public partnership. So NASA's putting their money into this thing to make these things happen. This is a different route for the space agency.
It is the whole NASA's vision here with so-called commercial lunar payload services is to have this public-private partnership and to develop a moon economy. So I still don't quite understand what that is. But you can only send so many, packets of grandpa's ashes, or so many, advertisements that you can take a picture of your product on the moon or something. I don't know what comes after that. But the idea is that NASA is seeding these companies to the tune of about $100 million each. Each mission, the winning bids are somewhere in the range of $100 million. That sounds like a lot of money, but it's not, because they have to pay for their launch costs out of that. So that most of them are buying Falcon 9 rockets from SpaceX at some tens of millions. I don't know how much exactly, but the bottom line is there's only tens of millions of dollars left over to actually build and operate these landers. And the company that I'm working with is called Firefly. I'm advertising for them tonight. This is their company. This is the lander. It's going to go in January, it's their first moon landing attempt. They have a contract for a second one, and this one, we've been working on it for like 5 years. It's supposed to be fast. It's taking just as long as it's a space mission. Now the last associate administrator of NASA in charge of science coined these terms like FedEx to the moon. So the idea was, you give them your payload and they give you data back for the moon. Well, that would be great, but it's still rocket science, and everybody still has to work hard to practice it all and get it all to fit and work. So it's just complicated. The other thing that he coined was this very unfortunate expression, more shots on goal. Meaning that we're gonna take risks with these $100 million missions, and if a couple of them fail, that's okay, because we're sending so many of them. Well, the first 2 failed. So, the goal is pretty good at the moon so far. But yeah, so, we're next on the runway. The launch and landing dates are not entirely public yet, but the launch has been specified as being mid-January. Yeah, so that's why my schedule with SkyWatchers is in flux, because we don't know. We get 2 months, 2 weeks of operations on the moon, so they're very short missions. These first generation of landers is not designed to last the lunar night. They land like right at dawn, they last for lunar daylight, maybe some hours into darkness.
It's 14 days
Yeah,
day and
sorry.
then 14
14
night.
days, day night.
Yeah,
So in contrast to the South Pole, though, our landing site, you go backwards. Let me go back. Let me do it for you.
okay, yeah, thank you. I told you I wasn't ready.
I just want to go back to this.
Okay,
So, because we have a convenient picture of the moon. So instead of being down here at the pole, our landing site is here. It's called Mare Crisium. You can easily see it as a dot, a dark dot that's separated from the rest of the dark parts of the moon. So the dark parts of the moon, of course, are giant lava, ancient impact basins that were later filled with lava. And this one, is a 300-mile diameter crater, basically, that later got filled with lava. That's off by itself. It's interesting, not just because it's off by itself, but it turns out that everything on this side of the moon is kind of chemically anomalous. So everywhere that Apollo landed, and Apollo did all the Apollo landers are in here. Sorry, I'm waving at the screen soon, people. Okay, good. That's why you have that camera. Excellent. Yeah, so we're gonna land in a spot that's it's on the near side. It's still a lava plain, but it's expected to be different geologically in the interior of the moon that we're interested in from the rest. So yeah, fingers crossed that works. And then yeah, they're on a pace to do 2 a year, going right through when the astronauts land. I mean, the astronauts will, if that actually happens in 2028, well, that's going to be the big news. But there's still going to be robots going too, as part of this big push for back to the moon, in principle for good.
yeah,
All right, anything else?
that was great.
Okay.
Let's give Bob and wish him well on this adventure of a lifetime. And hopefully we'll have him come and talk about how successful everything worked. Being mean Mr. Me, good luck. I hope it all goes. One other thing that's coming up that you should be aware of is Jeff Bezos at Amazon has invested quite heavily in a Blue Origin company that he's founded, and they are on the edge of launching their first vehicle, the New Glenn, and it's a very capable vehicle. If you read the documents, it hasn't flown yet, so we don't know how capable it is. But anyway, it's on the launch pad. It's coming up. It's going to be something to watch. It's going to be clearly a competitor for payloads like Elon Musk and those people. So, again, Jeff Bezos is a big new factor that's going to be a dynamo if it all is successful. He's invested in Florida, where this vehicle is stacked and ready to go. And we'll see how he does on this private adventure in 2025. It's a gamble, and he's got some of the great professional engineers working on this vehicle, and plus he's smarter than hell. I mean, he's like Elon Musk in a lot of ways. When you listen to him talk about his rocket, it's not like he's making up stuff. I mean, this guy's got some details, and it's pretty impressive. So hopefully we'll have a new booster that is all private, and That's a great segue into 2025. It's going to be something.
So it's
Uh,
like bigger, excuse me, Len, it's bigger than a Falcon 9, but not as big as a Starship.
Yeah, something like that. I don't, yeah, I think that's right. Starship is really quite a bankroll. I mean, it's going to be something. Starship, to me, one of the big things that's going to happen with Starship, if the moon landing program is ever going to be materializing, starships have to refuel in orbit. And that hasn't been proven yet about starships. And depending on what engineer you talk to about refueling in space, we haven't done it. And so not to the degree that this vehicle is going to need. So we'll see how Elon Musk does on that. But meanwhile, my talks here usually get into China because I spend a lot of time trying to watch China. It's not the easiest. It's not like dialing up NASA every day and getting 7,000 press releases. But China has a very aggressive program, not only for the moon, but also for Mars. And right now they have 3 of their taikonauts up in their space station right now as we talk. But what the tempo of the media in China is getting into more aggressively in the last few months is they're moving. They're going to go. They got already returned robotic samples from the moon. That capability is going to be matured, and they are depending on that to give them the capability to land their own crew on the moon. What they want to do is land on the South Pole of the moon and set up what they call the International Lunar Research Station. It'll be a lot of robotics, but also human tended. So and their plan is like in the 2030 timeframe. So we'll see. They also have a very impressive new development about their what they call the Mars Sample Return Mission. And it mirrors a lot of what we want to do in the US for returning samples from the red planet. So as always, what to me, what this signals is really exciting in the sense of I'm old and I went through Sputnik. And this is the beeping sound from China, big time. That's the place to watch. And they're moving out. And how this plays on Capitol Hill with NASA. And are we behind? Are they ahead? Can we work together? These are all open questions. And I think it's a great saga for 2025. And I think we got some surprises coming in 2025 about cooperation with China. And we'll see how that rolls out. We were just talking about Dream Chaser, Sierra Space locally. We've had some briefings here on Dream Chaser. Barb and I just luckily got invited down to watch a simulation of the Dream Chaser rendezvousing with the International Space Station. I think on the left there's Barb's shot of the control center. What's amazing to me is that we have these little control centers popping up in all these private groups. And it's not like your Apollo, Mercury capsule, Gemini. We have rows and rows and rows and back rooms and all this other stuff. This is down to 12, 15 people sitting there with laptops. And it is pretty amazing the capability that now private groups can have about running their own mission. But Dream Chaser is coming. If everything goes right, maybe May. What was the last thing we heard? I think it may be May. We'll see the first robotic Dream Chaser. It's down at Kennedy Space Center now being prepped for launch. It's a uncrewed vehicle with a large cargo capability that will haul new stuff to the space station. But the best part of that is it has wings. It comes flying back down to Earth, fully reusable, can be used 15 or so times over and over again, and lands at Kennedy Space Center, as well as some other potential airstrips, tarmac landings. So that's a 2025 new thing that we're going to see. One hopes it works, and we can crow about it because it's built in Colorado.
And one of our SkyWatchers, Stephen Langton, works at Sierra Space.
Yeah.
And maybe some of you were here for his presentation on that.
We'll have another briefing on that as if this thing goes as well as they hope it does. But it's definitely going to be a game changer. Probably the best thing that happened last year, in my mind, was trying to get this thing off the ground. It's an amazing capability that's en route eventually to get to Jupiter. I can't remember what year it was, but it's numbers of years from now. But it's getting Jet Propulsion Lab built this spacecraft and has some incredible instruments on it. But the main thing is to get to Jupiter and then do a reconnaissance of the Jovian moon, the Europa. And, Europa has been a kind of a astrobiological question mark for decades. And we're not sure, we've had up close images of this crater broken facade, ice. There's the ice there. We're not sure what's underneath the ice, how deep it is, but the potential of, I'm not saying whales under the ice, but I mean, people are very excited about what signals are going to come out of a Europa Clipper mission. And, as far as understanding more about an icy moon and what potential that has for astrobiology to be a life signature that we may see out from this moon. And, with all the new exoplanet detections, with a lot of moons, who knows what we're dealing with here, but this is a good trial run to better understand, moons and the icy capabilities of these places to uphold life. So that's probably one of the most exciting things that happened, at least in my coverage. I think that's it. I mean, I'm guilty of not doing a lot of different things that happen. 2024, I tried to just go back in my own notes and try, it was just too much. There were so many things that really happened this year. We also had some really interesting kind of quasi mistakes. And one of them was the Boeing Starliner flew to the space station. This is another private vehicle like the Dragon is for SpaceX. And it had some problems. I mean, they have two people on board. I'm not saying they're stranded on the space station, but the Boeing Starliner did not work to snuff. And NASA decided not to put people back on it to bring them back down to Earth. So they brought it in automated, and it was a successful landing. Everything worked fine. And it was a bad eyesore for Boeing. Nobody knows exactly what the future of Starliner is going to be, but the two people that wrote it up are still on the space station as we speak, as they fly overhead tonight. And they're coming back in a month or so, or a couple months. So they've been up there quite a while. They thought they'd be down, after a few weeks or so. So anyway, that happened. The other thing that's kind of interesting, Japan had the first ever lunar soft landing in January of this year. That was pretty impressive. again, robotic, and they have great schemes for the moon themselves. There's another mission coming called NASA Lunar Trailblazer. That's going to be launched on the Intuitive Machines mission that will go off next year. It's a small spacecraft with powerful sensors to look for water ice. As Bob talked about this whole thing about resources on the moon. Are they there? What kind of resources? Can you get to them? How much does it cost? How hard is it to process those things? I mean, water ice on the moon would be the elixir of future ideas about using that as rocket fuel, oxygen for a base on the moon. So the water ice situation is very important. However, the moon is littered with a lot of other stuff. And just a couple of days ago, I mean, there's been a kind of move toward helium-3. You know, there's a Japanese spacecraft is going to be launched probably next year, and it will have an instrument on there to look for helium-3. Okay, it's a rare earth, and why do you need helium-3? Well, I don't know. People think fusion reactors would be great if you could sell it to people that are trying to make fusion reactors. But there's also a lot of other applications for helium-3. So, and that gets into the bigger complex of things about lunar economy. Are we seeing the moon become part of an economy that we can actually derive materials from the moon and use them for some kind of benefit, either on the spot or back here on Earth or somewhere in between? Fueling, making fuel, putting it in cislunar space so other spacecraft can use it. Who knows? But that's why I love this stuff. It's just like a who knows. I'm always on a writing frenzy about who knows. It's always fun. So I think that's it for me. Probably the saddest thing that I think happened, our little Ingenuity helicopter crashed. Now, it was on Mars and it was doing 72 flights. There were people that fought tooth and nail not to do a helicopter on Mars. And it's a great story of somebody's dogged, going after it as a test bed on Mars to try a helicopter. And when it first flew, it was like the Wright brothers on Mars have arrived. And that thing kept going and going and going, 72 flights. And it was pretty impressive. And it eventually it crashed, and actually the Perseverance rover is getting to a place on Mars. The Perseverance rover is NASA's rover on Mars. It unleashed the little helicopter that flew all these times, and it went over and looked at where it crashed, and we sort of understood a little bit better about why. And then it's moved on, the rover, and it's up, way up above Jezero crater where it is, and it's about ready to look back down to see where little Perseverance, where the Ingenuity helicopter is still sitting. Broken, but it's also providing data. It's actually a little weather monitoring facility now. It has some capability to use its instruments to relay back to Earth some data that's useful. So, it's been 2024 was an amazing year. I think we're going into, as always, it's the Yoga Berra thing, when you come to a fork in the road, take it. NASA to me is caught between a moon and Mars rock and a hard place. And we'll see how they fare in the next year. I think China is definitely aggressive with their capabilities. I think that'll play well on Capitol Hill to put more money into NASA. But you have to ask whether NASA is spending the money wisely. We got a lot of field centers. Will they close down some? I mean, this new NASA administrator, along with Elon Musk, looking at government organizations and bureaucracy, and have we gotten way out of control? And how do you hone, what the government does and get more value for your dollar? And so we'll see. I've been here too many times with too many administrators that have come in with that kind of philosophy, and somehow I'm still talking and wondering whether or not NASA can be the agency that we want it to be. And so it really is a public, public is going to have to raise their hand and say, how much is space program really worth, and how best to do it, and what's the government role? All this new commercial private capability, how's that going to fare? So one way or another, 2025 is going to be a totally wild year. That's it.
I got a question for you, Lynn.
Yeah.
I had not heard about the helicopter crash on Mars. Did they know why? Was it operator error? Did parts wear out?
No, there's a new story just out the other day, and I haven't read it yet, but
Terrain recognition failed.
yeah, and
They're flying over sand dunes.
yeah.
Oh, the blade hit.
They said that initially they thought the blade hit the sand and broke off, but apparently the blade may have broken off on its own. That's what I thought I read. So we'll
The
see.
landing was unsuccessful because
Yeah,
landing was botched because they couldn't recognize any landmark features in the
Right.
sand dunes
yeah,
to get the height right. And I think when it hit, it went over and broke.
yeah.
But it still has solar power, so it could still.
Yeah, I mean, it was, again, it wasn't even supposed to last that long, and they just kept pushing the envelope on that helicopter. And they got more than they bargained for, and it was great. And there's no doubt now that helicopter is going to be a part of Mars exploration in the future. One big thing I didn't talk about, I mean, there is a huge decision coming. It could have been this month, probably not, about the Mars sample return. This is a mission NASA wants with the European Space Agency. It's tagged at between 10 and 11 billion dollars to bring back samples from Mars. And the current NASA administrator said, no way, we're not doing it for that. And it's too long away. Let's try to get industry to come in. Let's get all the people thinking about it. There's a new decision is coming about the Mars sample return. Meanwhile, China is already crowing about they're on track to do their own Mars sample return. So it's like a little race, but bringing samples back from Mars is an amazing capability, but who brings them back first? I don't know. Maybe that's a bad thing. Maybe we should do it. Maybe China is going to share with us what they get out of it. But Mars is so diverse. One sample or any samples from a specific area is not the answer to what Mars is about. There's a lot of people looking at low-cost missions on the polar regions where life may exist. I've seen all kinds of new ideas about diving into caves on Mars, which exist. Is that where life is? So, it's a great planet to hone your astrobiology skills, but that decision's coming shortly. And it really means a lot because it's a lot of money one way or the other for NASA. Meanwhile, the Artemis program with the humans on the moon, that's a huge amount of money, and they're going to have their own problems. So how all this dollar flow happens is really, break the window, get the dice out and roll it. I don't know. It's gonna be tough. Okay, thank you for listening to my ranting on this.
All righty. I'll give you a second to set things up for
John,
Joe. All right. There's that.
So sorry.
All right. We're just about ready, but I just want to say at the very end, you can all come up to the front. And you'll notice, take a picture of the group. Tend to run down the mountain messenger. I think it looks impressive.
Yeah, as Barb said, before we bother putting away the chairs, which is normally what we do at the end, go ahead and pose and get our family picture here of everybody. And then we're gonna wrap things up. I did want to mention one thing, apropos of nothing. Those of you who watch Channel 7 News might be familiar with Mike Nelson, who's their meteorologist. He's been a meteorologist. He's just retired after 48 years as the meteorologist channel. He was initially here, he was Channel 9, and he did that for like 10 years, and then he went over to Channel 7. And he's definitely one of the best meteorologists we've got, and actually did some of the early work on computer graphics for weather forecasting back in the 70s and 80s. But the other day I was watching the show, and he gave a book, souvenir book, to one of the other news anchors as a present because it was written by his college roommate. And Mike Nelson's college roommate was Scott Tibbetts, who was the guy who gave our last presentation at SkyWatcher's a month ago. So the last thing I expected when watching Channel 7 News was to see Scott Tibbetts' name come up. So I thought that was pretty cool. Okay, John, you are sharing the screen. We are ready for you to take over.
Are you sure?
Well, okay.
Well, all right. So it took me some time to think about how to maybe set up what we are interested in 2024. And so I started with, what were people searching on Google? So you can actually mine this information. And we are interested in sports. And I thought even with the solar eclipse, maybe it would reach the top 10. It maybe was sitting at about 100. So yeah, that wasn't very helpful to try to come up with what, types of news was interesting in 2024. So a lot of this Leonard just talked about, these are the top space related searches in 2024. The Artemis moon mission tops it. There's NASA's Viper rover, MMX from Japan, Europa Clipper mission, the asteroid mission from the European Space Agency, SpaceX Blue Origin, Lunar Trailblazer, and China and stuff like that. Well, that's a little helpful, more so. And then I thought, well, what kind of astronomy? We're talking about astronomy in 2024, what happened? And well, we are event driven when we are looking for astronomy related news. The total solar eclipse actually, is number one astronomy related thing. And then we're looking at meteor showers, the comet. I never get this, the Atlas Tashunchen, or I can't even pronounce it right. That comet in October, which was spectacular. Partial lunar eclipse, which was in September. Planetary alignments, all these things, they were the big astronomy related searches of 2024. But so I tossed it all out and I just went with what I think has been the coolest stuff, the most important news in 2024 in the astronomy area. So, we live in the atmosphere of a star, and but we don't understand it very, very well. It's very hard to observe. It's hard to get close to, and we have this little or a couple of probes that are actually doing a pretty good job. And this story came out a couple weeks ago about the European Space Agency Solar Orbiter probe made the first ever connection between measurements of the solar wind around the spacecraft itself to the high resolution images that it gets also of the sun's surface, so at a close distance. And the idea here, the solar wind is a steady stream of electrically charged particles that stream out from the sun continuously, but we don't understand the origins of it very well. And so what the solar orbiter did is it actually connected the in situ measurements around the probe itself with the magnetic charged particles coming off of a sunspot. And so by the time these things reach Earth, it's a pretty muddied mess. We're not able to really tell. It takes maybe 3 or 4 days for that solar wind to reach Earth. It doesn't travel at the speed of light, but it does travel fast. And, by that time, we're not really sure what thing we're looking at the sun is producing the particles that are getting to us. So being close to the sun, they were able to fly this spacecraft through a magnetic field that was connected to a sunspot. They saw solar wind speed changes that they were expecting. And, they were using that camera on board. This is the image they got. I mean, this is a pretty spectacular image all by itself. And what's cool about it too is that, I'm with the National Solar Observatory, and to help them, make these measurements, they're using one of our programs called GONG, which we have 6 telescopes around the world that monitor the sun almost continuously. And so it's kind of neat that we're working together to make that happen. Another sun related, we get a little movie there if you want to watch it real quick. Another sun story that's pretty interesting is that super flares are huge things that, flares on the sun, they're electromagnetic bursts, usually visible in white, invisible light, but they release a lot of other light in other spectrum like X-rays. And so there was an event in 1859 called the Carrington event. I've talked about it before, but it was an event that a guy named Carrington observed back then. It was really a coronal mass ejection. This material came off the sun toward Earth. And we've been having aurora as far south as New Mexico and Texas. This past, we're in what's called solar maximum right now. The sun has an 11-year cycle of it goes down to, the sun's not very active, which we measure in sunspots and things like that. And then right now we're in maximum. So we have a lot of sunspots, a lot of solar activity. But the Carrington event, when it happened in 1859, the only technology we had on Earth was the what's it called? Anyway, we just had the Morse code. What is that called? Anyway, it was what? Telegram. Yikes. Telegraph machines. They were reporting operators were getting shocked using the telegraph. So thanks guys for bailing me out on that one. So operators getting shocked. The wires that are going between poles, there were some reports of melting going on. So what happens during this interaction, these magnetic fields interact with our magnetic field on Earth, it grounds out in, as electricity on Earth. So if this happened now, a Carrington event, they would, it probably overwhelm the power grid. Navigation would be affected, communications will be affected. Us biologically not affected because we're protected by the Earth's magnetic field, but technology seriously impacted during an event like this. These super flares are 50 times more powerful than that. We used to think that maybe they occurred every 10,000 to 100,000 years. That was what some of the research in the past has done. But there's a new study came out this week in Science that says they looked at 56,450 sun-like stars from the Kepler survey. And between 2009 and 2018, they found 2,800 super flares on 2,500 sun-like stars. And so that really equates to super flare every 100 years instead of this, 10,000 to 100,000 years. So we are either way overdue for a super flare, or the possibility is our sun's not as active as these other stars out there. So stay tuned. Hopefully nothing bad will happen. Yeah, it'll be serious. And this is why we want to understand the solar wind and the origin of it and how the magnetic fields come and interact with the Earth. And right now we basically have detectors here on Earth, so we don't have much warning. And this is one of the things that, just like the astronomy has a decadal survey, the solar community has one that they just released last week. And it talks about, the need for this monitoring, just like we want to monitor fireballs and meteor impacts on Earth. I think one of the things that I found most interesting in gathering all this stuff that I was interested in and I thought was really important was the level of detection that we're getting to is becoming really, really impressive. So we gather this data from fireballs. This is from 1988 to December 1st this year. And what we see is that fireball detections, and we detect these things using, optical cameras and sound, ultrasonic type of detection. And these detonations, when these asteroids or these meteorites come in, they're distributed uniformly across the planet. That big red circle over Russia is the Chelyabinsk meteor fireball that happened a few years ago. And also we are using one of the newest tools is the lightning mapper on the GOES weather satellite. And so in the past, we've used observers, like if you're in Coal Creek Canyon, you can report, I saw a fireball coming in at this angle and stuff like that. There's a lot of bias in these observations, or people aren't spatially aware. And so there's, this GOES satellite, removes a lot of that ambiguity. So they also, what's kind of cool about this is they're using the same technology they use for searching for extrasolar planets. And so they're using, in another kind of related story, is they're using that technology to find really faint objects out in the asteroid belt, things that might be a danger to Earth. And we're talking, right now, we are seeing objects, bus size after they've passed Earth. That's a little late. So this new technique that they've just announced that's related to this is that using these the same technology for extrasolar planet searching, they can stack images, see what kind of faint objects are changing in the way they in the images, and then maybe these things are outshining the noise. So we're able to check those out. And they're detecting objects down to the tens of meters out in the asteroid belt using this new technology, or this new method, which I think is kind of cool. A meteor like this killed the dinosaurs 65 million years ago. This is what's considered a carbonaceous chondrite meteorite. This is actual meteorite that hit Earth. They found in Antarctica. But according to this article in Nature, these kind of meteorites are pretty rare. They form outside the orbit of Jupiter, and they're among the oldest types of asteroids and meteorites that they form near the beginning of the solar system. And excuse me. So according to the chemical evidence from the impact site at Chicxulub in Mexico, where they think the asteroid that killed the dinosaurs 65 million years ago happened, it suggests that this is the makeup of this asteroid. It also turns out that, when the meteorite hit the Earth, it threw up all this stuff, including glass particles that recongealed as little spherules, and they came back to Earth. These things got stuck in the gills of the dying fish, and it seems as if the asteroid probably impacted in early spring in the northern hemisphere based on the way these the fish fossils, how they can see the growth patterns of the fish, and it just happens to correspond with springtime for the fish growth. So it's similar to like reading tree rings. How wild is that? So cool. Obviously, we're moving from the sun outward into the universe, and Mars is next. NASA has this lander on the moon or Mars right now called InSight, and they've detected what they think is a really vast underground reservoir of liquid water. And it's enough to fill the entire or to cover the entire surface of Mars to a depth of about a mile. Unfortunately, it's sitting at about 11 to 0.5 to 20 kilometers down in the crust, and it's tucked away in little crevices and pores of the geology down there. And that's about 7 to 13 miles. Even on Earth, this type of drilling would be a challenge. So there may be a lot of water on Mars, but it's not available to future Martians, not without a lot of work. So that's kind of a bummer, but interesting stuff, right? We're learning more and more. We've always want to think that Mars may have been habitable in the past. And by studying a meteorite that landed in Antarctica, that's from Mars, the chemical signatures point to it having a Martian origin. This is a study out of Curtin University in Australia, and it looks like the little chemical analysis of this asteroid or this meteorite matches. It could have only formed the zircon in that meteorite could have only formed some of the chemicals inside of it could have only formed in the presence of water. Now, this thing is about 4.1 billion years old, and so this is about the same time. This is about a billion years after, or about a billion years after the planet formed, during a time when there was a lot of volcanic activity or meteoritic activity on Mars, so that we see this heavily cratered surface. But having the water present at this time, this is about the same time that we think life formed on Earth. It's possible that maybe, since there was a lot of water on Mars, these minerals, they formed in a water-rich environment, maybe that there was life on Mars. And that's one of the missions that the sample return mission is hopefully going to answer, right? So we'll stay tuned for that story. We're moving way out now. This is a cool new image from the Event Horizon Telescope showing the Sagittarius A. This is the massive black hole that's in the center of the Milky Way galaxy. And this is in polarized light, this new view. And polarized light is like this. Light's kind of both a wave and a particle, and it oscillates, and it's affected by magnetic fields. And when it does that, when you look at light through a polarized lens, say your sunglasses, and you rotate it, you see that the sky gets a little darker, and then you rotate it back, it gets lighter. That's polarized light, and that's the light's affected. It's kind of in a preferred orientation. That's polarization. Anyway, so what they noticed was that the magnetic field structure of Sagittarius A is very similar to another black hole they've been studying in the galaxy M87. And they wondered, even though M87 is 1,000 times more massive than our black hole in the Milky Way, they wondered, what is it? Are there more similar traits than the look of it? So based on the previous studies of the light, they found that the monster black hole launches powerful jets of material into the surrounding environment. And the scientists are seeing the same thing with Sagittarius A. And so they think, this is one way that they can show that magnetic fields are critical to how black holes interact with the gas and dust surrounding them. Instead of just gravity, there's also a magnetic field component. One of the things that we've been trying to figure out for years and years and years is we see stars are moving in ways that normal physics, based on Einstein's general theory of relativity, which has been proven over and over and over again, and we'll talk about it here in a minute again, is that these stars around we're studying stars that move around like the outside of the galaxy near the edge. They're moving faster than they should be. And the only explanation that we can think of is that there's matter that we can't see. We call it dark matter. And so the galaxies, we see this stuff, but the theory says that there must be this huge halo of dark matter. So there's some researchers at Case Western Reserve University in Cleveland. They cataloged about 130,000 galaxies. And right now in this image, we see these arcs. These are called Einstein arcs or Einstein rings. What happens is that these arcs are actually galaxies that are on the other side of a massive gravity well from a galaxy or a quasar. And the light is coming through towards us, but then being warped by gravity, by intense gravity fields. And so under the prevailing model of cosmology known as lambda CDM, and I couldn't tell you what CDM means, these dark matter clumps around these big globs, they're able to attract visible matter and make these arcs. But does this mean that there's more dark matter than previously thought because things are moving differently in the universe? This new theory says maybe not. Maybe there's a rival theory to lambda CDM known as the modified Newtonian dynamics, or MOND. And this theory does away with dark matter altogether. And it seems as if the new measurements that they're seeing with these, 130,000 galaxies are predicted by MOND and not by this, the current lambda CDM theory. So again, stay tuned. Dark matter may or not exist. We don't see it. We haven't detected it. It's been a matter of contention for years, but we shall see. But we did have a new study that sort of validates Einstein's general theory of relativity. This is an image from an instrument called the Dark Energy Spectroscopic Instrument at the Mayall Telescope at Kitt Peak Observatory down in Arizona. It's mapped nearly 6 million galaxies. This image just shows 400,000 of them. And what we're looking at here is that the disk of the galaxy sort of blocks the views so that dark area is the disk of our galaxy. And we're looking at the top and the bottom. So you assume that distribution goes on and on and on. But if you look at this image a little closer, it's a little noisy, but there is kind of a pattern in there. And so the experiment is in its 4th year. There's going to be 5 years of this thing. And they're going to be able to collect, they're going to be looking at 6 million galaxies across 11 billion years of the universe. Okay, so if you think about how the universe started, we think that the universe is maybe 13 billion years old, but that's starting from a center. So the observable universe is really more like 20 or 30 billion light years across. Anyway, so at the end of this survey, they're going to be looking at 40 million galaxies and quasars. And by studying how the galaxies and clusters across this big time, it kind of reveals the growth of the cosmic structure and provides a better test for gravity at really large scales. So, cosmic scales, or galactic, I don't know, it's beyond cosmic, it's universal scales. Anyway, so what's cool about this is they're able to test the theories of modified gravity, which is an alternate explanation to the universe accelerating expansion. So the idea behind the Big Bang is that there was this huge inflation when the universe was created, and then it's just been accelerating ever since. One of their observations from DESI lineups with Einstein's general theory of relativity. So another part of this theory is being played out. And one of the weird suggestions here is that maybe dark energy, which is kind of a component of dark matter, is something that scientists or astronomers have created to sort of explain what's going on. It might be weakening as the universe ages. This is going to be one of those questions like dark matter. Is it or isn't it a thing? And I would be hard pressed to tell you why this matters, other than, the ultimate end of the universe is what they're going for, right? So, eventually it'll matter, but not to us tomorrow. Still interesting to figure out. Another part of this is that, the James Webb just keeps impressing the crud out of us this year. And one of the goals of the James Webb was to really probe what's called the cosmic dawn. The universe was opaque, like until about 100,000 years after the formation, what they call ABB, or after the Big Bang. And what's cool is it's continuing. The Webb keeps finding these supermassive black holes. This is what it was meant to do. It's looking at the universe in this near infrared, which, these little black holes, or these supermassive black holes that are far, far away at the beginning of time, really, they're glowing out there, and this is what the Webb is supposed to do. So they found a black hole after about 1 billion years after the Big Bang. That's about 4 million solar masses. Now, this is about the same size as what we just saw, the Sagittarius A supermassive black hole in the middle of the Milky Way galaxy. But they've been looking at black holes that are about 700 million years with 40 million solar masses. And this is much, much larger than they would have predicted. So this is kind of a question mark that's sitting out there. What does this really mean? Well, Webb is giving us a glimpse of the black hole mergers and the rapid growth much earlier than we would have expected in the universe. This means that when I say the universe is running out of supermassive black holes, it means we would expect to find not as many. We wouldn't expect them to grow as rapidly as they did. This is kind of a oddity, question mark, big question mark. Another thing that is coming out of Goddard Space Flight Center, another NASA laboratory, is that teams of scientists, not just one team, but many, many teams around the world have been reporting this low pitch hum. We see the similar thing with cosmic background radiation. This is the kind of what we believe. This was discovered in the 50s with our radio telescopes. There's this noise that's sitting just about a few degrees above the absolute zero background temperature of the universe. We're seeing from the Large Laser Interferometer Gravitational Wave Observatory, LIGO, This became in the news a few years ago because it detected what we think are the collision of black holes from billions of years ago that are producing these really, really minute waves in gravity. So the detector has these lasers that are spread out across the whole Earth, and they moved ever so slightly, and they were able to measure that. We think that was a gravity wave moving past Earth. And so these scientists using this information, they've been seeing a lot of these kind of this background hum that's going on. And the only way they can detect these very faint vibrations is using a very huge antenna by using millisecond pulsars that are spread across the Milky Way galaxy. So they've been looking at these pulsars. These pulsars, they give off signals at a very precise, regular rate, and they're each unique. They're like a fingerprint. And so by comparing them, they see this hum. And so they're thinking maybe this hum is caused by dark matter, primordial black holes, or maybe even cosmic strings, which is another feature of the new cosmology that we've been studying the past 10 or 20 years. Another thing, Webb, it does provide us cool images of the Andromeda Galaxy or the Orion Nebula, which I'm not going to show you tonight, but it's also teased out from this image of just tiny little bit of space is this most distant galaxy called JD's GS Z14-0. Now you might ask, how do they know it's the most distant galaxy? Well, we talked about the Big Bang, and there's this thing called redshift, where the farther things are from us, it's a form of measurement, and it seems like the farther things are from us, the more redshift we see. This is the spectrum of a galaxy is shifted toward the red, so it's really stretched out. And this thing has a redshift of 14.32, which it's kind of a number, right? Well, this is a huge number in the redshift terms. For comparison, if you look at the Andromeda Galaxy, which is actually moving toward us, so the light is blue shifted, so it's compressed and it's pushed more toward the blue end of the spectrum, or this way, is that the redshift blue shift of the Andromeda Galaxy is 0.00042. This equates to about 125 kilometers per second. The Andromeda Galaxy and the Milky Way in 4 billion years are going to collide. The Andromeda Galaxy is much like twice as massive, so it's gonna do some wacky things to the universe. Our view of the sky is going to be crazy. Now, what I really love about this image is that there's some 6-pointed stars in there. 1, 2, over 3 of them. I see 4 of them, 5 of them, 6 of them. Those are stars in our Milky Way galaxy. Everything else is a galaxy far, far away. And it just blows my mind every time I see these images of the whole universe is just filled with galaxies. Crazy stuff. All right. So what to expect in 2025? If you look at the sky tonight, Mercury is a morning object. Mercury is very hard to see, but it's worth trying to get up early. It rises tomorrow at 4:42, so the sky is going to be a little bright, but you might be able to detect it, like near the horizon. Venus is the bright object in the evening sky right now. Jupiter rises on the other side of the sky. Like right now, it rose about 5 o'clock, so it's sitting, 30 degrees up in the sky. That's Jupiter. Saturn is right behind it. It rose, actually it rises earlier, so it's a morning it sets about 11 o'clock. So Jupiter's setting at 5 in the morning. So Jupiter or Saturn right now is, over toward in the western sky. And what we can expect for January, these are the events that I think are worth watching, is that Mars is going to be in opposition in January 15th. What this means is it's brightest for the year. It's what it means is it's closest to Earth. The Earth is directly between it, Mars, and the sun. The image I've got in the background is the Pleiades being occulted by the moon, and this takes place near midnight. This image happens at about 1:30 in the morning on February 6th. So through a telescope, this is going to be pretty spectacular. Now, the moon's going to be a half moon, so it's going to be a little hard to see. And then another thing to look for, March 13th, 14th, is a lunar eclipse, total lunar eclipse here in North America. On May 1st and 2nd, the night there, we will be able to see Vesta with the naked eye. This is kind of a cool thing that you can watch. In August, Venus and Jupiter are going to meet in the morning sky. So Venus then, moves after it's being so bright now in the sky. It's going to move into the morning sky. And then in September, this is the best time. Saturn's going to be at opposition. And right now the rings are nearly edge on. So this will be a really interesting view. And, something to look forward to for 2026 is the total solar eclipse in Iceland and Spain. So plan your trip now. It's going to be a super cool thing. And that is it. Oops. I'm going to show you some pictures that I've taken. Here's Andromeda Galaxy, and we have the Orion Nebula and the Horsehead Nebula. Images I took just a couple weeks ago.
Wow.
Thanks. Happy holidays, everybody. If you have any questions, I'll try to answer them.
Anybody have any questions, you guys? Not here, Zoomers? All right. Well, I think that's a wrap. And Zoomers, good night.
See you guys. Thanks a lot. Happy holidays.
Thank you, John. All right, folks, let's get up front.